What if the next great leap in electric vehicle technology has just been revealed? Imagine a new family of electric motors, so compact they fit directly inside the wheels of a car, eliminating the need for a transmission. Imagine them being so powerful they can deliver over 4,000 newton meters of torque to a single wheel. Now imagine this same design cutting a vehicle's weight by hundreds of kilograms and slashing manufacturing costs by as much as 50%. For decades, engineers have dreamed of this reality of embedding electric motors directly into vehicle wheels, but a wall of technical challenges always held them back. Until now, a technology company called Donut Lab has unveiled something truly disruptive. A full lineup of donut-shaped, in-wheel motors that promise to make transmissions, axles, differentials, and even engine compartments obsolete. Their platform can eliminate up to 120 individual components in a single compact SUV, slashing build time by 8 hours per vehicle. It offers the highest torque and power density of any EV motor in the world, capable of achieving a 0 to 100 km/h launch in under 2 seconds. What you are about to see may be the biggest change in electric propulsion since the dawn of Tesla, yet few are discussing it. At the heart of this story is a new class of electric motors. Donut Lab, a modular EV technology company, has not just introduced a single motor, but an entire family of them. 5 new donut-shaped motors, each designed to be installed directly into the wheel rim. This means there is no need for drive shafts, no need for gearboxes, and no need for a bulky central motor. Each wheel becomes its own independent, self-contained power unit, a plug-and-play system ready to drive. This isn't just a matter of convenience. It's a direct solution to some of the most pressing challenges facing EV manufacturers today. High manufacturing costs, excessive vehicle weight, inefficient component integration, and an overly complex drivetrain. For the first time, there is a single modular motor platform that can be scaled to fit every vehicle category, from tiny, lightweight drones to massive, heavy-duty trucks. Let's talk about the numbers, because they are staggering. The largest of Donut Lab's new motors is a 21-inch wheel-integrated monster. It weighs just 40 kilograms, yet it produces an incredible 630 kilowatts of power and 4,300 newton meters of torque per motor. That is enough force to launch a standard passenger vehicle into hypercar territory or completely redefine the capabilities of a heavy-duty truck. In a hypercar configuration with 4 of these motors, the system delivers a total of 1,500 kilowatts of power and 9,000 newton meters of torque, good enough for 0 to 100 kilometers per hour acceleration in under 2 seconds. Even more shocking is the semi-truck implementation. This system saved over 1,000 kilograms in weight while generating a colossal 18,000 newton meters of torque and slashing material costs by $15,000. Need something for motorcycle? Donut Lab's 17-inch model generates 150 kilowatts and 1,200 newton meters of torque, and it weighs a mere 21 kilograms. There's even a 12-inch variant for scooters and a miniature version for drones that weighs only 1.5 kilograms while still delivering 3 kilowatts of power. These figures don't just match the current market, they obliterate it. Donut Lab claims these are the highest power and torque densities ever achieved in a commercial motor of their size. But what's even more groundbreaking is that these motors break the traditional trade-off between torque and power. Historically, engineers had to choose: optimize a motor for high torque or high power, but never both. Donut Lab's architecture delivers both, all within a smaller, lighter package. If in-wheel motors are so great, why haven't they already taken over the market? The biggest hurdle has always been the problem of unsprung mass, the weight of the motor being part of the wheel assembly, which can degrade ride quality and handling. Donut Lab asserts they have finally cracked this code. By maximizing torque and power density, they have made their motors so lightweight relative to their immense output that the added unsprung mass is now negligible. Heat management is also covered, with each unit built using an advanced thermal design to keep the motor cool even under demanding conditions. And for durability, These motors are sealed, ruggedized, and ready to withstand the vibrations, mud, and moisture of real-world driving. This is more than just a concept. These motors were demonstrated live at the CES event, and Donut Lab is already offering them to OEMs for integration. Removing the traditional powertrain changes everything. Without a central motor, transmission, or differential, vehicles become dramatically simpler. There is more room inside the cabin for passengers and cargo. The vehicle's weight distribution becomes more balanced, and maintenance gets significantly easier. For manufacturers, the cost savings are substantial. In the traditional model, parts from dozens of suppliers need to be integrated, tested, and calibrated, a process that is both expensive and slow. Donut Lab solves this with a modular technology platform. Their motors are designed to plug seamlessly into a vehicle's software and hardware ecosystem. They even offer standardized battery modules, control computers, and vehicle management software, all built to work together natively. For manufacturers, this means faster development cycles, fewer bugs, and far less integration work. You don't have to build an EV from scratch anymore. You just pick the parts from a catalog and click them together. One of the boldest claims from Donut Lab is that their technology cuts manufacturing costs not just through simpler assembly, but by reducing the amount of active materials used. Because their motors deliver more performance per kilogram, less material, less copper, fewer rare earth metals is needed to achieve the same output. This efficiency extends to the entire system, allowing for smaller batteries and smaller cooling systems. And since each motor is a self-contained unit, repairs are modular as well. Just swap out a wheel unit with no need to dismantle the drivetrain or crack open the chassis. Donut Lab's approach is flexible by design. Want to build a high-performance sports car? Use 4 of their 21-inch units and prepare to break some records. Designing a delivery scooter? Drop in the 12-inch motor with a tiny control module and you're done. By building everything on the same architecture, Donut Lab can support vehicles across every category while giving engineers total control over form and function. This isn't just a motor family, it's a full electric propulsion ecosystem. With all these breakthroughs, it's fair to ask, what are the limitations? Right now, one challenge is scaling production. Manufacturing high-density motors with this level of precision isn't easy, especially if demand spikes. Then there's industry inertia. Car companies have decades of supply chains, factories, and partnerships built around traditional layouts. Moving to a wheel-centric design means changing everything, and that takes time. Of course, Donut Lab's claims, while impressive, will need to be validated over time through millions of real-world miles. Still, the signs are strong. The motors are real, the performance is real, and now they're out in the world. All signs point to yes, this new motor family could very well be the future of electric vehicles. For the first time, in-wheel motors have broken past the limitations that held them back for so long. Donut Lab appears to have delivered record-setting performance, solved the unsprung mass problem, simplified vehicle design, and slashed production costs, all within one elegant modular system. If these motors deliver in the field the way they perform on paper, we might be witnessing the start of a new and revolutionary chapter in electric transportation.